Okay, so in 6.2, we are solving quadratic equations. So this is kind of chapter 4 and chapter 5 put together. We already have the skills to know how to do this. We just have to kind of understand what these questions are asking. So solving quadratic equations is, finding out how to make an equation true. And there's these synonyms here in green that questions are going to ask you in different ways for the same answer. So it could say solve, find the solutions, find the zeros, find the x-intercepts. There's even another one actually that I missed. Find the roots. And you'll understand where roots comes from in 6.4. But these are all synonyms. So it all means the same thing. It means find the value of x when y equals 0. So I have 3 examples here. And some are already set equal to 0 and some aren't. So we can really only solve in math complicated things to get 0. It's really hard to determine how to get like the number 15 from something that we don't understand. How do I get 15 from here? I have no idea. But it's really easy to get 0 because if you factor it into its factors, only one of those factors needs to be 0 to throw everything to 0. So that's why we love working with zeros in math. So when we are solving for 0, first thing we have to do is we have to factor it because it's hard for me to determine, it might take trial and error, what to plug in for x to get 0 here. But if I factor this using my method of factor pairs, which, you have to know how to do, or you can factor it using decomposition. To get a 9, I'm using the 7 and the 2. So I'm going to factor this with an x, a 2, an x, a 7. I'm going to maintain the 0 there. Signs are the same. They're both positive. So we know how to get here from chapter 5. Whatever method you take to get here, we know how to factor. 6.2 allows us to go one step further than this. This means, what does this have to be to get 0? Well, if I plug in a negative 2 over here, I'm going to get negative 2 times, who cares, 0. So x is negative 2. That's one solution. And x is negative 7. That's another solution. And these are my 2 solutions. These are my 2 x-intercepts for this quadratic, for this parabola, whatever the case may be. And that's it. This is only the only new thing, and we kind of already know how to do that. Even tested on it too. Let's take a look at this. Sometimes we get stuck with trinomial factoring that we forget other factoring methods. So here they have an x in common because I don't have a c value like this 14 over here. So I could just factor out an x like this. And now I have 2 scenarios. I have an easy one right here. If x is 0, throws everything to 0. So I'm going to write that one down. And then I have this, which is a little tricky because there's a coefficient in front of x. So I'll show you how to do this, and then I'll just show you a quick shortcut. This means I want to figure out when 2x plus 5 is equal to 0. So I could bring the 5 over and make it negative, and then I can divide by 2. So this is my answer. But it's really easy to just always say opposite this sign over this. Negative 5 over 2. Done. Every single time. Negative 5 over 2. If you had an example with like 7x minus 3 in brackets equals 0, the answer is opposite this over this, 3 over 7. Done. Okay, so there's not really a reason to do this once you figure it out, how to do it the quick way. Could present some problems when the numbers are rearranged, but solve those when we get there. Now, like I said, it's hard to get something that isn't 0. What do I have to plug in here to get 15? No idea. So while your first intuition after a question like this is going to be to factor out an x, that's wrong. We only want to do anything when one side of the equation is 0. So first we have to bring this 15 over to the left side. So I'm going to get 6x squared minus x minus 15 is 0. And now I have a 0 on one side, and now I can factor it. I can use 1, 6, 2, 3, 1, 15, 3, 5, and I have to subtract to get a negative 1 in the middle. 15 and 6, no, 9 and 10, there it is. 3, 3, and 2, 5. I open up my brackets. Whatever method you choose to factor, you can use. 3 is with the 3 on the inside. 2 is with the 5 on the outside. Signs are different. The bigger pair is negative. 9 and 10. 10 is bigger, takes the negative. So you need to know how to factor. You need to make sure that the signs are right. Because when we go into the x-intercept, you're going to get the wrong intercepts, even if your signs are wrong. So right here, opposite this over this. Over here, opposite this over this. These are my 2 x-intercepts. Done. Okay. Could get a little tricky if you don't know how to factor, but factoring is extremely important, or you can't solve quadratic equations by factoring. Okay, I'll show you a word problem now. Okay, so in a question like this, we have a rectangle. We know its dimensions. I can draw the rectangle here. Doesn't really matter what the shape is. Oh, it looks like a square. Well, it's not, because I'm saying it's a rectangle, so get at me. 3x plus 1 is one dimension, 2x minus 5 is another dimension, and the area is 1150 centimeters cubed. I got to figure out what value of x is going to make that area true. So I can start by writing my formula for area here. I can say area is length times width. Then I'm going to plug in everything I know. Well, I know 1150. Doesn't matter which one's length, which one's width. So the first one I see, I write first. 3x plus 1. And now I can't solve here because this is not 0. And if I move this over, I'm going to subtract 1150. When I have a subtraction, I am not factored. It has to be multiplication. So first I have to expand this, right? Without this 1150 being here. I have to expand this. Then I have to bring the 1150 over. Then I have to refactor. So it's a bit of a process, especially with numbers this size. It could get pretty annoying. So I'm going to expand this. 2x and 3x is 6x squared. 2 and 1 is 2x. That's negative 15x, and that's negative 5. And now I'm going to bring over the 1150 because it wants to join with that 5. I'm going to collect some stuff over here. These guys in the middle can turn into a negative 13x. And this on the outside over here is 1155. Now, is this going to be a pain in the ass to factor? First of all, I'm going to see if there's a common factor, but there's not because 13 is prime. Or else I could divide everything by that common factor because 0 is on this side. So I have to strap up. I have to factor with a 1 and a 6, a 2 and a 3. And what a pain in the ass this is going to be, this 1155. Yeah, is it going to take you some time? Sure, right? You can just find one factor and work from there. It shouldn't take you that long, trial and error, because there's only 6 and 1 and 2 and 3 over here. But anyways, I discovered that it's this. And now I can factor it. It's going to be x minus 15. Again, this process right here is going to take you the longest amount of time to get from here to here. But for the video, I'm just going quick. 6x plus 77. Okay, so now I'm factored. I did whatever I had to do. 15 with the 6. I paired these guys. And now I'm going to find my solution. So x is either equal to 15 or x is either equal to negative 77 over 6. Now, because I can't really get negative 77 over 6 over here, because if I plug in a negative number over here, I'm going to get a negative dimension, and that doesn't make any sense. So I actually have to reject this and accept just this 15 as my answer. Not all the situations are going to be true. Remember, when we have parabolas over here, we only care about the positive realm. Like all this negative time, we can't really associate with our question. So this is kind of the same idea. There's always going to be two answers, but one is going to be more appropriate than the other. Sometimes both are going to be appropriate. Sometimes none are going to be appropriate. So we have to kind of extend our knowledge there. So it says, what are the dimensions? Well, now I can say, therefore, the dimensions are, and I plug this 15 into here. So I get 15 times 2 is 30, 25 centimeters. I'm going to plug the 15 over here. 45 plus 1 is 46 centimeters. So the dimensions are 25 by 46. So again, expand, collect your like terms. So there's a 0 on one side. Refactor if you can. In this section, you probably can. Once you refactor, this is going to take you the longest. Solve and analyze whether your solutions are valid in the scenario. Find the one that's valid, plug it in, conclude, done. No problem. And that's 6.2.